Hey everybody, Mr. Dickman here. Today we are going to talk about conditional probability and the multiplication rule. So the way that this works is first you have to determine whether two events are independent or dependent. So independent events are events in which the first event does not affect the second event. Flipping a coin is an example of an independent event. Every time I flip the coin, it doesn't matter what I had gotten previous to that. I'm still have the same probability that I'm going to get a head or a tails when I flip that coin. Okay. So mathematically, the way that we talk about this is for two independent events A and B, the probability of both events occurring is the product of the probabilities of each event occurring. So you can see that the probability of A and B, and being the important word here, is just the probability of A times the probability of B. Now that is only for independent events. So let's do an example. So we roll a number cube, also known as a die. Then you roll it again. What is the probability that you get a 2 on the first roll and a number greater than 4 on the second roll? Well, the probability that I get a 2 and then something greater than a 4 is going to be equal to the probability that I roll a 2 times the probability that I get a number that is greater than 4. Now, what is the probability of rolling a 2 on a die? Well, there's 1 2 on the die. There's one number that's favorable. That's the favorable outcome. And there are 6 numbers I could have gotten. So the probability of rolling a 2 is 1 out of 6. The probability of getting something greater than 4, now if we're talking about greater than 4, then 4 is not included there. So there's just 2 numbers that are greater than 4 that are on a die. That is a 5 and a 6. So there are 2 numbers out of the 6 numbers that I could have gotten. So I multiply these together. Okay, I can reduce this a little bit to make the multiplication easier. This is 1 over 3. And so the probability of rolling a 2 and a number that's greater than 4 in a row is 1 out of 18. So I can take this number and leave it a fraction, 1 over 18, or I can put this into my calculator and turn this into a proportion, which is 0.056, or I can turn this into a percent, and this is 5.56%. So these are all the different ways that I can write this probability down if I'd like. If the problem specifies fraction, write the fraction. If the problem specifies a proportion, write the proportion, that's this one here. And then if the problem specifies a percent, then write the percent. So we toss a coin twice. Here's another example. Find the probability of getting 2 heads. So I'd actually like you to pause the video right now and try to do this on your own. And when you're ready, unpause it, and I will go through the solution. All right, you ready? So we're going to toss a coin twice. We want to get heads twice. So we're looking for the probability of getting heads and then heads. So that's the probability of getting heads times the probability of getting heads. The probability of getting heads is 1/2, and the probability of getting heads is 1/2. And so the probability of getting heads twice is 1/4, or 0.25, or 25%. These are all valid answers to the question. All right, moving on to the next problem. there are 6 green, 4 pink, and 6 brown marbles in a hat. You pick 2 marbles from the hat. Marbles are returned after they have been drawn. So this is the important part here. The marbles are returned. So they go back into the bag, or hat in this case. So these marbles go back into the hat after we take them out. So we take out a marble, we look at it, and then we put it back in the hat. So we want to find the probability that the first marble is pink and the second marble is brown. So that's going to be the probability that the first one is pink times the probability that the second one is brown. So that would just be probability that we pick a brown one out. So the probability of getting a pink one, since there are 4 pink marbles in the hat, and there are 16 marbles that I could have picked out of the hat, the probability of picking a pink marble out of the hat is 4 marbles, 4 pink ones, out of the 16 total. And I'm going to multiply this by the probability of picking a brown marble. So there are 6 brown marbles in the hat, and there are still 16 marbles in the hat because I replaced the marble that was in, that I picked out. Let's say I did pick out a pink one the first time. I put that marble back. Okay. So I just need to multiply these together. Again, I can have my calculator, I can use it, or I can reduce this a little bit. This fraction, 4 over 16, can be written as 1 over 4, and 6 over 16 can be written as 3 over 8. And that definitely makes this a little bit easier to multiply. We multiply across, so we get 3 over 32, which, as a fraction, you could leave it 3 over 32. As a proportion, it's 0.09375. You could probably cut that off here and round to 3 decimal places, making it 4. Whatever you want to do. And this would also be 9.38% if I made a decimal, or I made a percent to 2 decimal places. So let's just do this here. Okay. So these are all valid answers. It did not specify that we wanted a fraction, a proportion, or a percent, so I'm just going to leave my answer all 3 ways. Okay, so those are all independent events.